All right, and now I just want to have a quick discussion on SD-WAN. I am not here to teach you all about SD-WAN. I'm here to make sure that you prepare properly for the exam. So, SD-WAN, software-defined WAN, is what? Software-defined wide area networking. It's really a technological shift and a mind shift for us when it comes to wide area networking. It says here SD-WAN is a technology that utilizes software-defined networking principles to manage and optimize the distribution of network traffic across a wide area network. It offers the ability to dynamically route and prioritize network traffic based on factors such as application type, network conditions, and business policies. So, let me compare that to my traditional WAN that I might have. My traditional WAN might be just a simple MPLS connection between all of my different sites that I have. Or it might be IPsec site-to-site VPNs I have. Or it might be DM VPNs that I have set up. What's the difference then between that type of WAN setup versus SD-WAN? Well, the difference is managing, monitor, maintaining, control, automation, programmability, which I don't get with traditional WAN networking. All of those buzzwords I just threw out there are greatly enhanced when we're talking about SD-WAN. The ability to dynamically route and prioritize network traffic based on factors such as application type, network conditions, and business policies. I don't get that with traditional WANs. So with SD-WAN, here's your buzz list of benefits. Drag and drop the benefits of SD-WAN. Of the following options, please pick benefits of SD-WAN. Improved network performance, shorter installation times, cost savings, centralized management, application-aware routing, flexible and agility, security enhancements, redundancy and failure, cloud readiness, all compared to what? Traditional WANs. That's great. Thank you for all those buzzwords, Cisco. Great marketing words that I may need to know for the exam. Why would I want to choose SD-WAN over traditional, folks? Boom, there you go. Those are great ones. Are they going to test you on its limitations, though? Of course not. But I'll tell you some limitations, so that way you don't think I'm a fanboy of SD-WAN and I'm just trying to promote it. Okay, initial investment. Woo! How many of you have implemented SD-WAN and the cost was a lot? I once had a student who went through Encore with me. Yeah, Andrew's like, yep. I once had a student who went through Encore with me. And she went through CCNA, Encore, and RC. My gosh, like she went through everything. And her growth was phenomenal. She learned everything she could, studies. It took years, but my gosh. In the end, she contacted me. She goes, hey, I just got contacted by Cisco, none other than that, and they really want me to invest in SD-WAN. She goes, but I don't see the benefit for me. So we had a conversation about it, and in the end, it was like, no, the numbers are like astronomical. It was like 50 times cheaper to just go out and buy like new ASAs and just simply set up IPsec site-to-site VPN tunnels and DM VPNs and stuff like that and just go that route, because she didn't need all that extra stuff, a lot of those extra benefits. She didn't need the centralized management. There wasn't enough sites that it would make like the cost-benefit analysis. The flexibility and agility was not enough to justify the costs. The security enhancements, again, was not enough to justify the cost, because with the IPsec site-to-site VPNs and the DM VPNs using IPsec and all that, I mean, you got the security you want in that case. So, and again, the redundancy and failure, all that type of stuff just wasn't enough to just justify the cost. So, initial investment high, complexity, right? Initially learning about it, doing it, yeah, it is complex. Dependency on internet connectivity. So here's the thing. One of the things that you see in a lot of marketing things is like, oh, you know, when it comes to SD-WAN, right? You don't have to worry about your connections. Of course I do. I still need an internet connection or an MPLS connection or an LT connection. I still have to pay for that. I still have to work with my service provider to get that set up before we can do SD WAN anyways. What am I doing with SD WAN? I'm building a virtual network on top of those connections. That's what I'm doing. I'm building a virtual network on top of those different types of connections. So I still have to deal with all that other stuff, and that other stuff can still be costly. There are security concerns as well when it comes to what? Securing this stuff now, especially if it's in the cloud. I can totally lock in myself on a vendor now. That's right. You can have quality of service issues. You can. I mean, although there are built-in mechanisms so you don't, you totally can, especially if all of a sudden you are on the backup path and it's the internet because it dynamically flipped over to that and it wasn't supposed to, maybe. It can happen. There are integration challenges. There's a learning curve. Right? Some of the things here is they say like centralized management is supposed to save you money. That's a benefit. That's only if once you finish doing SD-WAN, you are no longer really worrying about it. And it's just working as it should and magically doing everything it should without you ever having to get involved. Yeah, that's where you get savings. But if you're constantly managing it, you're constantly having to dive in, you're constantly have to verify this, verify that, troubleshoot just, then, I mean, you're in no better shape than you were before. So when I hear a lot of the buzzwords for SD-WAN, for me personally, it's marketing stuff. And in the end, it's up to you to figure out, are we really going to benefit from this before you pull the trigger? That's important, right? Now, that is not part of the exam, okay? Some of those buzzwords, yes, okay? Like if they ask you, what are the benefits of going to SD-WAN? Okay, know this stuff, right? Pick it out of like, I'm going to have cost savings, whether it's true for you or not in the real world. I'm going to have shorter install times. I'll tell you right now, some people have had longer install times in the beginning, but down the road, right, when they added sites, it was shorter. You see, there's the payoff, right? If you're constantly growing and evolving, then yes, over time, you can save on time, money, energy, right? That's over time. But if you set up SD-WAN and it's that forever, you may never save. It's really tough to know. You got to do your cost-benefit analysis for the real world. Okay, that's me telling you personally about stuff like that. So for the exam, though, I really need you to be able to pick these 4 names out of a lineup for the certification exam. That's your number one goal. Do you know what orchestration plane is? Do you know what management plane is? Do you know what control plane is? Do you know what data plane is? Number 1. So what is our orchestration plane? So folks, our orchestration plane is going to be the device, whether it's on-prem or in cloud, that has the ability to do the onboarding of our entire SD-WAN. So here is some keywords to keep in mind. Orchestrates the control and management plane. So it's about onboarding all of the other devices, vManage, vSmart, are what? Are edge devices, whether they're virtual edge devices or physical edge devices. Orchestrate them, onboard them. It is the first point of authentication as well. Are these devices and services actually allowed to be part of this SD-WAN architecture? It then has the ability to distribute the vManage information and the vSmart information to your edge devices, virtual and physical edge devices. So meaning your routers that form your tunnels over the WAN. They can do NAT traversal or facilitates NAT traversal VBOD. It's going to have a public IP address. Why? Because it needs to be reachable over what? The internet. And it's going to be a highly resilient device of some type. Meaning you're going to have to make sure it is resilient because it's responsible for the onboarding of your devices when they come up. Right? Key things to keep in mind, key things to remember when it comes to your vBond device, the orchestration plane. So yeah, in your on-prem data center, you can set up your vBond. right? Or you could set it up in Cisco, AWS, Azure, and what are we setting up? We're setting up a server that has the ability to do the orchestration for us. Right? Now, what about the control plane? Let's jump down to the control plane. So the control plane is this device right here. We call it vSmart in the world of Cisco, vSmart. And what are we dealing with in this case? We're dealing with our controller for the control plane. Now, I'm not talking about like your graphical user interface. I'm not talking about that device. No, that's vManage, right? In this case, vSmart is our software-based component, either on-prem, Azure, AWS, Cisco, running on a virtual machine, something like that, okay? And this software-based component is responsible for the centralized control plane of the Sd Wan network. So what is it going to do? It's going to learn everything that you have defined. So it learns about all the policies that you've defined. Through what? Through your vManage console that you have. So it learns how the network needs to be based on the policies that you have defined. It's your centralized enforcer of policy and control. In addition, it can learn, as you can see, learn from other devices. So already it's learning from vManage through you, or vManage monitoring statistics and measurements and realizing something's wrong and then telling vSmart dynamically to make a change to the environment. Or vSmart can learn even from the edge devices directly. So that way it can make adjustments or changes on the fly, all depending on how you set it up and how you want to use it. So some things to keep in mind, vSmart is going to be used for what? Facilitating the discovery of your fabric. So what devices are part of that fabric? Through what? Through vBond as well. vBond has to let it know, right? Who is part of this fabric? Who do we need to register? Who do we need to work with? And so on and so forth. And so this is your control plane information for all those edge devices. So the edge devices are about what? Data plane, forwarding traffic. That's your edge devices. Your vSmart is the brains. Think of it. Brains making decisions. That's vSmart, control plane. And then it tells the data plane, tells the edge devices what to do. Through what? Through things like routing policies, security policies, any other types of policies that you set up. So it reduces your control plane complexity. So here's one of the powers of SD-WAN over traditional WANs. In traditional WANs, folks, how many control planes do you have in a traditional WAN? Okay, the number of control planes you have in a traditional WAN equals the number of devices you have. So if you have 100 WAN routers between headquarters and branches you have, then every single one of those devices have their own control plane that you have to manage, monitor, and maintain. But if you switch to SD-WAN, now you've got one centralized control plane and a backup, hopefully, okay? Therefore, dramatically reducing the control plane complexity. So all the brains of all the devices are here now. And you want to make sure it's a highly resilient device. So when we talk about learning information from vEdges, right, we can gather what? Telemetry data from WAN devices. That's what we can do. And when we tell things, distribute routes, policy, security, right? That's when we are updating it on, what do you need to do? How does your VPN need to be set up? How are you going to handle traffic? What protocols are you going to use to secure it, et cetera, et cetera. All right, then we got our data plane. So the data plane is what? That's where you're going to have your physical edge devices or your virtual edge devices. So virtual edge devices could be, for example, like a virtual router that is set up in the cloud in an AWS network or a Cisco network. So that way there you can have your cloud infrastructure as part of your WAN architecture. So that way there you are going to have the same policies on that WAN architecture as you in the cloud as you would in your headquarters and branch offices, as an example. Right. And then maybe your branch office and headquarters, you'll have physical devices, but you could still have virtual devices where maybe you have a server set up. So the traffic comes in, it first goes to the server, wherever in the branch office, let's say, and then can go out to the users as it goes through that edge device. So whether the edge device is physical or virtual, doesn't really matter, right? They're going to be responsible for the same thing. And primarily that is traffic forwarding, security, encryption, quality of service. But how does it know what to do? How does it know how to forward traffic? How does it know how to secure traffic? How does it know how to encrypt traffic? How does it know how to do quality of service? Well, that comes from who? That comes from vSmart. And we said vSmart learns from what? From you configuring policies through vManage as an example. Right? It can learn from the edge devices that are constantly working and then sending data to vSmart. So then vSmart can say, oh my gosh, wait a second, we've got such and such an issue with quality of service. Let's go ahead and adjust what we're doing. So that way there, we don't have the quality of service issue anymore. But our edge devices, not vSmart, let me take off that circle now, but our edge devices like this device right here provide secure data plane with remote edge routers, establish a secure control plane with vSmart controllers using a protocol called OMP. So OMP is the overlay management protocol. That is the protocol that runs between vSmart and our edge devices. So that way there, we have the opportunity to talk to each other. So whenever we have policies that from vSmart that need to be told to the edge devices, we use the overlay management protocol in order to accomplish that. Implements data plane and application aware routing policies. We can export performance statistics up to vSmart from our edge devices. We can use traditional routing protocols like OSPF, BGP, VRRP, other things like that with our vEdge edge devices. We get zero-touch deployment, meaning like plug-and-play type of deployment, where let's say we had another branch office coming up, we get a new device, we put it in, we'd have to go to our vManage and do the initial, provide the information that we need to into vManage, and then from there, vBond can do what it needs to do from an orchestration standpoint and onboard that particular new device into our vManage and everything else that goes on with that, and confirm that it's actually a true Cisco product that's registered and paid for it and all that stuff through serial numbers. There's a lot going on there. And then, as I said, we got physical devices and virtual devices with many different port speeds to accomplish whatever you need. And then lastly here, we have vManage. vManage, I want you to remember, is your management plane. This is your dashboard for management. It's your single plane of management for Cisco SD Wan. So on the exam, just think about how you might be tested on these. What is your centralized network management system in SD Wan? It's called vManage, not DNA Center. DNA Center is for SD Access. vManage is for SD Wan. DNA Center is for SD Access. vManage is for SD Wan. That's what you might be tested on. Right, you got your graphical user interface to easily monitor, configure, and maintain your Cisco SD-WAN environment. So, vBond, onboarding. vManage, management. It's your dashboard, your graphical user interface. Control plane, vSmart. Brains, data plane, edge, vEdge, power, brawn, forwarding. That's what it's all about. So, OMP, I mentioned it. I want to give you a little bit of details for it in case anything comes up like this on the certification exam. So, OMP stands for Overlay Management Protocol. It is TCP-based control plane protocol. So, essentially, we're creating a TCP session from here to here. From here to here. So, that runs between what? It's going to run between our edge devices, virtual or physical, and vSmart. And we are using this protocol inside of a dynamic TLS, transport layer security connection. So how is OMP being protected inside of dynamic transport layer security, DTLS? So DTLS is going to be used to create secure control channels between what? Edge and vEdge devices to vSmart, Edge or vEdge devices to vManage, Edge or vEdge devices to vBond. And if you have multiple vSmart controllers, vSmart to vSmart controllers. we use dynamic transport layer security connections. So now with OMP, this is, like we said, about sharing the information that we need between the brains and the forwarders. So edge or V-edge devices to vSmart for information sharing. Remember that for the exam. How do we share information? OMP. How is OMP protected with DTLS? So some of the things that we will share using OMP, reachability information. So vSmart needs to tell our edge devices who they can reach, who they can form tunnel with, who they can route to and from. So subnets, routes, T-locks. T-locks are called transport locators. T-locks. That sounds an awful lot like R-locks, right? Well, yeah, same idea. Each of our edge devices need what? A locator ID. Well, we call them T-locks here. So that way there we have the ability to create a tunnel from this T-lock to that T-lock. So they have to learn dynamically about those T-locks. They have to learn about subnets. They have to learn about routes. You learn that from vSmart using OMP. What about security parameters, like the encryption keys? Again, that's got to be sent over a secure connection. So that's using OMP, using DTLS. So whatever I specified up here, I said, okay, for encryption, we want to do this. For the integrity checking, we want to do this. So remember when we set up our site-to-site IPsec VPNs? I mean, there's a lot of work there, wasn't there? I had to specify everything, and then I had to copy and paste it to all the different devices. So now imagine if we had 100 devices. So you can see where Sd Wan can make your life a lot easier. I can now specify the policies here, and then my devices can learn those policies. And I don't have to go from device to device to device to device. So if I wanted the same policy for all my devices, well, then I just have to configure it once, and my devices can learn about it. But if I wanted to have different policies for certain devices and certain groups of devices and different things like that, well, then we can group them and do our things and, and get those different policies done that we want. So you can see where, yes, that definitely in a really massive, large-scale environment, using SD-WAN, if you don't already have something set up, may be the way to go. But then again, right, cost-benefit analysis, are we going to benefit from this long-term? If I spend all this money just to set it up now, and we don't expand or grow or add, then nothing changes. So technically speaking, could we spend all that money on a human being configuring it once on traditional and just go with that and save money without having to pay yearly fees to Cisco for all of this stuff to keep working? I mean, you got to make that decision. It's a tough one. It's a tough one. I like it. Don't get me wrong. I like it. But if it doesn't make for me, if it doesn't make sense financially, it doesn't make sense doing it. Right? So depending on the environment, yes, it would make total sense to do this. Other environments, no. Policy information. Data policies, app route policies, right? Policies saying if traffic is here, wanting to go there, it's allowed. But if it's this going to there, it's not allowed. What if you're using this app? Then you can't. But if you're using this app, you can. So we can get very granular with these policies, which is another added bonus. Whereas when you think about something like traditional IPsec, it's really more about what? Subnets, VLANs, right? That's really it. Ports, source and destination ports, whatever you can do in an access control list. But here, I mean, we get to be a lot more granular because we would be able to maybe even inspect the traffic and say, hey, this type of traffic, we don't want to allow it over that tunnel because that's not traffic that should be going over that tunnel. So you're denied, you're blocked. So we do have the ability to have like application aware routing here now in this particular case. We have the ability to do database routing. We have the ability to enforce all of that based on our policies. Right. All from what? Again, a centralized location. Now, when the tunnel's actually created between two devices dynamically on the fly, what type of tunnel is that? It is an IPsec tunnel. So when you are managing everything and you're defining your security policies for your tunnel, you're going to have to use the IPsec framework. So what protocol, what this, what that, what encryption algorithm, right? All that still has to come into play here. So you still have to learn about IPsec, even though you're using Sd Wan. But then again, some people don't learn about it, and they're just like, I'll just pick the most strongest one possible for every single option. Which may or may not be a good thing. It really depends on the scenario and situation. We get our secure transport of user data from one site to another. So based on the fact that I have interesting traffic that arrives and it needs to go from here to here, based on everything that I learned from vSmart, I can go ahead and set that tunnel up and encapsulate my traffic. And based on everything I learned over here, I can then decapsulate that traffic. Also, the tunnel uses what? Bidirectional forwarding detection. Hey, that's pretty cool. What did we say bidirectional forwarding detection could be used for in our dynamic routing protocols? To detect an outage across the link between two neighboring devices. So if I had, for example, my router here and my router here, if the interface goes down, or not interface goes down, but if I have issues with that connection, even just across this link, it could take up to 40 seconds for OSPF to make a change. But if I'm running BFD from here to here, from here to here, we said that we could detect a change within milliseconds, and then OSPF could make its adjustment right away instead of waiting for its dead timer to expire. So we utilize BFD here to what? Make sure that I have a connection from here to here. In reality, okay, it's not from the tunnel. It's, do I have a connection from here over the internet over to here? That's what BFD is doing, right? Can I get from my public IP connected either to internet, MPLS, or LTE? So it might even be a private IP address with MPLS, right? But can I get from that IP address over to the IP address over there, the tunnel endpoints? So that's one thing it can do. It can test connectivity. If there's a loss, then we could use a backup path. So for example, maybe we're primarily using MPLS. Well, if MPLS goes down, maybe we'll have a backup of the internet. If internet goes down, maybe we'll do a backup of LTE. So we might be paying for all three of those connections, but the router is set up based on your policies to use MPLS first. If BFD detects a failure, then fall back to the internet. If the internet fails, then fall back to LTE. Possibilities, right? These are all things that we can do. So if there's a loss, we can fail over, right? We can also, though, measure latency here. So what if all of a sudden this is becoming very saturated and we're not getting the performance requirements we need? Well, then if the latency level gets too high, then we have the ability maybe to switch over to one of these other options on the fly. Same thing with jitter. If jitter gets too high, the jitter is the variation in delay, variation in latency. Well, if that's what is detected, then we can go ahead and maybe fail over or switch over to another one of our connections on the fly. Right? So I already mentioned failures, so an entire failure, but what about just loss? If we have excessive packet loss across that, then maybe again, if packet loss gets too high, we can fail over to one of the other connections that we have. So if you have, for example, like the need for mission critical connections with certain loss, latency, jitter, and failure values associated with them, Sd Wan gives the opportunity to dynamically change on the fly, whereas something like our traditional WANs don't do that. So there's a little added benefit as well to that one. That may be beneficial to your organization. Now, when it comes to these IPsec tunnels, though, what we need to realize is that our IPsec tunnel can actually be, what's the word I want to use here? Segmented into what? Into different VPNs. So let me give you a visual representation of what I mean by this. So let's go ahead and zoom into our IPsec tunnel, and you will see inside of the IPsec tunnel, you can have different VPNs. So I want you to be careful with that on the exam. See, on the exam, when it comes to SD WAN, right, your IPsec tunnel, that's not your VPN, okay? Whereas when we talked about IPsec site-to-site VPNs, well, that was one VPN, that was your IPsec tunnel. That's essentially what we built. But with SD-WAN, our IPsec tunnel can be compartmentalized, or segmented, I should say, into different VPNs. And therefore, each VPN gives us isolation. Kind of like VRFs, right? We now have different tunnels that isolate and segment traffic from each other. They have their own forwarding tables. Oh, this is sounding a lot more like VRFs. So we have what are called sub-interfaces under each VPN, or associated, I should say, with each VPN for this IPsec tunnel. And then we'll have to label each of these VPNs with our through OMP information, through OMP route attributes is how you say that. So that way there we can do the proper packet encapsulation, which identifies the VPN a packet belongs to. So there are two types of VPNs that exist by default. You have VPN 0, which is what we call the transport VPN. It contains the interfaces that connect to the WAN transports. And then we have VPN 512. That's a management VPN that exists, and it carries out-of-band management traffic for us to and from the Cisco SD-WAN devices that we have. And then you can have as many custom VPNs as you need. Right? So multiple VPNs can exist in a tunnel. Each VPN has its own forwarding table. That's what I want you to take away from that. And that's what you need to know for SD-WAN for the certification exam, folks. So, know orchestration plane and what it's about. VMan or data management plane, what it's about. Buzzwords, keywords. Control plane, data plane, right? So vBond, vManage, vSmart, vEdge, and Edge at a minimum. And then everything else we talked about, good things to know, except for those little side discussions I went on based on my own personal feelings. Those are not going to be on the exam.